Hello friends, I am Dr. S.P. Patil. In this video, we discuss about the Newton's ring. So before we start the Newton's ring, we will discuss about the formation of Newton's ring. So initially I will draw the diagram. Now this is traveling microscope. Now this is source of light. This is lens L. Now this is the plain glass plate which is inclined at a 45 degree. Plain glass plate. Okay. Now this is plano convex lens. And this one plain glass plate. Okay. Now we discuss about the formation of Newton's ring. See, now when a monochromatic beam of light is focused on this lens L, after that the ray of light is normally incident on this plain glass plate which is inclined at 45 degree. After that, from the plain glass plate, the ray will be reflected in downward direction like this. Okay? And that ray incident light is reflected back from the surface of the plano-convex lens. Plano-convex lens means what? Its one surface is plane and other surface is convex. Okay? And this plano-convex lens is placed on a plain glass plate. Understood? So this reflected light, or when this reflected light is made to incident on this plano-convex lens, then a part of that light is reflected back from the curved surface of the plano-convex lens, and a part of light is reflected back from the plane surface of the plain glass plate. Okay, so these reflected or these two reflected light interfere with each other and produce interference pattern which is in the form of circular rings, like this we get. Understood? So one more time I will explain. When a ray of light or a monochromatic beam of light focus on the lens L, then the light will be normally incident on the plain glass plate which is inclined at 45 degree. After that, from the plain glass plate, the ray will be reflected in a downward direction. Okay? And incident on a plano-convex lens which is placed on a plain glass plate. Understood? After that, a part of incident light reflect back from the curved surface of the lens, and a part of incident light is reflect back from the plane surface of the plain glass plate. So these two reflected rays interfere with each other and produce interference pattern which is in the form of the circular rings, like this. Okay? Now after that we discuss interference theory of Newton's ring. So we can write here interference theory of Newton's ring. Okay. So for this, we draw one diagram. Okay. Now here also a monochromatic beam of light AB is incident on plano-convex lens. Then from the point B, the ray or the light will be reflected like this, ray 1, and from the point B, a ray of light is refracted along BC. Again from the point C, the light will be reflected like this, ray 2. Understood? One more time I will explain. A ray of light or a monochromatic beam of light AB is incident on this plano-convex lens which is placed on a plain glass plate. There is a partially reflection and refraction occur. So from the point P, the ray will be reflected along this, called as a ray 1, and from the point B the ray will be refracted along BC. Again from the point C the ray will be reflected in this direction and give or called as a ray 2. Now these ray 1 and ray 2 both are coherent rays because these both rays produced or derived from same incident ray AB. Okay. Now after that already I have told you this is the vase-shaped film. At the point of contact the thickness is 0, and if we see this figure then it is observed that gradually thickness of this film increases. If this is the vase-shaped film, then we know that path difference between the two rays for vase-shaped film. So we can write path difference for cos of r plus alpha plus minus lambda. Okay. After that we know that there are two conditions. First one is constructive interference and other one is the destructive interference. So first condition for constructive interference. For constructive interference, we know that this constructive interference takes place when path difference between the two rays is equal to n lambda. And therefore, we can write the equation like this: 2 mu t cos of r plus alpha plus minus lambda by 2 is equal to n lambda. Now again, the left hand side term lambda by 2 will take into the right side. So we get 2 mu t cos of r plus alpha is equal to n lambda plus minus lambda by 2. So again we can write this equation like this: 2n plus minus 1 into lambda by 2. Okay. Now we know that for air medium the value of this mu or refractive index of air is 1. Okay. And for normal incidence, here I will write, for normal incidence, r is equal to 0 and alpha is equal to 0, and therefore the term cos of r plus alpha we get 0. So by putting mu is equal to 1 and this term is equal to, so we get cos of r plus alpha is equal to 1 because cos 0 is 1. Okay, so by putting mu is equal to 1 and this term is equal to 1, we get final equation 2t is equal to 2n plus minus 1 into lambda by 2. Here n is equal to, we can write 1, 2, 3 and so on. Okay. Now second one for destructive interference. Okay. Now again we know that the destructive interference takes place when path difference is equal to 2n plus minus 1 into lambda by 2. So we can write the equation path difference is equal to, or we can write the equation 2 mu t cos of r plus alpha plus minus lambda by 2 is equal to 2n plus minus 1 into lambda by 2. Now again here also the term lambda by 2 will take into the right side. We get 2 mu t cos of r plus alpha is equal to 2n plus minus 1 into lambda by 2 plus minus lambda by 2. Okay. Now here lambda by 2 will take 0, 1, 2, 3 and so on. Okay. Now again here by putting this refractive index of air is equal to 1 and this term is equal to 1, we get final equation 2T is equal to n lambda. So these are the conditions for Newton's ring. So one more time I will explain. Formation of Newton's ring. Here a source of light is there. From that source of light a monochromatic beam will focus on the lens L. Okay, and after that the ray of light is normally incident or focus on the plane glass plate which is inclined at 45 degree. Now from the plane glass plate the light will be reflected in downward direction like this. See this arrow? So the light will be reflected in downward direction and incident on a plano-convex lens which is placed on a plane glass plate. Okay. After that a part of incident light is reflected back from the curved surface of the plano-convex lens and a part of incident light is reflected back from the plane surface of the plane glass plate. After that two reflected rays interfere with each other and form the interference pattern which is in the form of the circular rings. So we get like this rings and called as a Newton's ring. Okay. Now after that we discuss about the interference theory of Newton's ring. For this, see this figure. Here also a ray of light or a monochromatic beam of light AB is incident on a plano-convex lens which is placed on a plane glass plate. Then there is a partial reflection and refraction occurs from the point B. So we get ray 1 and after refraction the ray will go along BC. Again from the point C the ray will be reflected and we get the ray 2. Now the ray 1 and ray 2 both are coherent rays because they are derived from same incident ray AB. And when these two rays interfere with each other, we get the interference pattern which is in the form of the bright or dark rings. Understood? After that, now this is the wave-shaped film. See here, wave-shaped film is there. So we know that path difference for the wave-shaped film, we can write 2 mu t cos of r plus alpha plus minus lambda by 2. Okay? Now we know that there are two conditions, condition for maxima and condition for minima. Now first we discuss about condition for the constructive interference. Now this constructive interference takes place when path difference between the two rays is n lambda. So we can write 2 mu t cos of r plus alpha plus minus lambda by 2 is equal to n lambda. So the left hand side term will take into the right side, we get final equation 2 mu t cos of r plus alpha is equal to 2n plus minus 1 into lambda by 2. Now again for air medium the value of mu is equal to 1 and if there is a normal incidence then the r and alpha both are 0 and therefore cos 0 is equal to 1. So by putting this value we get 2t is equal to 2n plus minus 1 into lambda by 2. Here n is equal to 1, 2, 3 and so on. Okay. Now second condition, that is for destructive interference. Now this destructive interference takes place when path difference between the two rays is 2n plus minus 1 into lambda by 2. So we can write the equation 2 mu t cos of r plus alpha plus minus lambda by 2 is equal to 2n plus minus 1 into lambda by 2. Similarly, the left hand side term will take into the right side. We get 2 mu t cos of r plus alpha is equal to n lambda. Here n is equal to 0, 1, 2, 3 and so on. Again by putting the refractive index of air is equal to 1 and this term is equal to 1, we get final equation 2t is equal to n lambda. So these are the conditions for Newton's rings. Okay.